It's a great pleasure to welcome Iryna Gurevych from Technical University Darmstadt. Many of you will know her. It has been mentioned she has worked out as sentence BERT and many other things. She is the head of the Ubiquitous Knowledge Processing Lab at Darmstadt, and she is interested in information extraction, semantic text processing, and machine learning. And as I said yesterday, to those of who were here already, she's also interested in applications of natural language processes to social sciences and humanities. And that's sort of the main reason why we invited her to join this workshop, where that is exactly basically the topic. So now you have about 40 minutes. Is that okay? And then we have about 20 minutes more to discuss. Please. Would you like to? Sollen wir es umhängen?
Das geht auch. Hi, good afternoon, everybody. Thanks for the introduction. It's my great pleasure to be here just to put my talk in a context of this wonderful workshop. I come from the technological side, so my area is natural language processing and artificial intelligence. And the talk will be about basic research in our field, right? So I'm not going to talk about end user tools. I understand there are many users here, but the main purpose of our work is to inspire future tools. So that's why we also work a lot on novel task definitions. So what can we do with this technology that cannot be done today? And this work is specifically something which is done in a larger context of an ERC advanced grant. And the main basic research question is to make natural language processing understand the connections between different documents. So what we can do quite well is to analyze single document, but when we need to relate pieces of information across document, the technology is not very mature. And of course, this task is extremely difficult because we have long texts. And that's why it's extremely demanding to create training data. And since we don't have much training data, the technology is not good in this context yet. So that's the main basic research goal. So the title is How to InterText. So InterText, basically how to connect documents. And also model the modification of these documents over time. Because nowadays, as you know, Google Docs overleaf. Documents are created collaboratively, and they have also an evolutionary process. So to contextualize the talk in this audience is quite easy. A lot of work is text work, and people in social sciences and humanities usually have this very advanced skill of reading and deeply understanding the text. But this is not only in social sciences and humanities, in many other areas. If you think about it, it's extremely important. So like in business, for example, or in education, we need to do with a lot of text. And while humans are usually very good at deeply understanding a small snippet of the text, when it comes to understanding longer texts, it becomes very difficult. So that's why this skill has to be learned in a lot of pain, so to speak, in social sciences and humanities, because it's very fundamental to these subjects. And an average human is not so good at these skills, for example, extracting arguments from a long text. Our memory and attention are usually very limited, so this is the challenge. And if we have to navigate not just a single long text, but we need to relate multiple long works to each other, it becomes even much more demanding. And of course, in the last time, many things in text work, this is what I call it, or knowledge work, have become much, much better since we have these large language models. And we also have very powerful search, right? So search has become really like basic instrument for everybody, recommendation system, information extraction. So all of this works pretty good at the level of individual documents. And also machine translation is quite impressive and can be used in production, conversational interfaces, and all of this is driven by transformers and large language models. However, despite all of this progress, as I said, some things are still very, very hard to support with technology. For example, the problem of misinformation and so-called fake news. It's extremely hard to trace the origin of information and to assess the quality of the sources, and AI cannot really help us here. It rather makes everything even worse because AI can be easily misused for generating false information intentionally or unintentionally. And also we still have very few tools for quality control of texts and for assisting reading of long texts by means of AI. And when it comes to collaborative writing, though we do have very convenient tools like Google Docs or Overleaf, Shared LaTeX, and similar, to some extent, there is no real AI support. So this is just an infrastructure for collaborative work, but there's no real intelligence that helps, for example, to resolve comments semi-automatically. If you have ever worked on a grant proposal with 10 other authors, then you know very well what I mean. It's a nightmare because you have a lot of comments and it's very hard to relate these comments to each other and also to classify them, what is actionable, what is not actionable. All of this so far actually is mostly manual work, and this is what we want to change long term with our research. So why is that so hard? If you think about a lot of text, probably we think about a long manuscript or a pile of documents. So this is what we call a static text. However, as I said, a document usually undergoes an evolution, especially when multiple authors work on a document and leave comments or make revisions. And also we have a chain of related texts and references, and all of this are interconnected documents. And if we want to really deeply do something with the document of our interest, we need to involve this contextual information and be able to identify relations across documents. And as I've already explained, humans are very, very bad usually at handling this because of our memory and attention constraints. So to study these cross-document relations, we need a framework that can model text basically as a living object in context. We have started this large project that we call InterText. And here what we want to do is to propose novel conceptual models of such cross-document relations, which are inspired actually by theories of intertextuality in literary studies. So we do not literally take them over because there are quite many competing theories, but we basically inspire our work, but all the expertise that went into creating these models, and we need to simplify them for our technological purposes. And we propose to model each text along two dimensions, time and context. So time is when a document is changed over time from one version to another, and the context is in relation to other documents. So in this project, we develop the conceptual models, as I said, but also we design novel tasks that involve multiple documents, create novel methods to identify cross-document relations, And of course, we release data sets that can be used in future work in order to push forward this whole field that will empower us to understand fine-grained relations between texts in time and in context. So this is the research team of the ERC grant. We started about 2 years ago. It's actually on the 1st of April, 23. So it's a comparatively recent project. However, the team is actually much larger. We have also projects that relate to this vision. And in the talk, I cannot cover all of our research output, so it's just too much. But I will cover some parts of our core work to give you like the basic understanding of the technology that we develop and also introduce some examples of ongoing research questions. So a lot of work in this project is centered around academic publishing and peer review. So actually under the umbrella of AI for science. So we work on this basic research, NLP and AI questions. And we have 2 case studies. So one is academic peer review and the other is misinformation detection, since these are very much suitable for our main interests. So we need to understand the relations between multiple documents in both domains. Scientific documents are very much suitable for our research because we have long documents that are very demanding, they are domain specific. And in addition, they are connected by citations. And a particular distinguishing feature, which is very important for us, we have multiple versions of the same document, since a manuscript, at least usually, would have a submission version and a camera-ready version, and potentially more versions in between. So however, published documents are just the tip of the iceberg. So we have this peer review. This is very often confidential. And in addition to the core document, we would have these review reports that we can relate to the submitted version and also to the final version. This would generate a lot of interesting data for our project, and this data is great for intertextual analysis because the texts fulfill these 2 main requirements. So the contextual information is very important, but also the text is evolving over time, and usually this happens within a specific infrastructure that we call a reviewing platform in science. And so kind of for collecting the data, this scenario is very convenient because all data is typically in one place, right? So if you think about news and Wikipedia article, you usually have a lot of heterogeneous sources, social media, so it becomes very, very complicated in legal and ethical terms. But in the scientific domain, there's a lot of content of the type we are looking for, and usually it's already collected in one content management system. So apart from that, peer review and scientific publishing, so at least from the perspective of machine learning, AI and NLP communities where I am anchored, face a lot of challenges today due to the literature exploding basically and the community growing very, very fast, presenting a lot of challenges for scientific peer review, right? So the number of papers is growing, the population of the scientists is completely skewed. So comparatively very few senior people who are experienced reviewers, but a huge number of junior reviewers with little reviewing expertise. So in our field, there is really a huge pressing demand to produce tools in order to cope with this amount of scientific information. So as I said, So the main focus today is this InterText project and cross-document relation, but in reality, the cluster of research under the InterText umbrella is much bigger in the lab. So just to give you an idea, we have different types of research projects. So one is like long document processing. So this is core natural language processing research. How can we effectively analyze long documents? For example, long documents would have structure, like, for example, section titles, subsections in different levels, and so on. And if you think about transformers, usually for them, it's just a stream of tokens. However, the semantic structure should be actually very important, and the layout information, because we humans, when we read long documents, we use this structure in order to prioritize our attention. So basically what we do here is we try to teach transformers also to integrate this kind of high-level structure in order to be better able to focus on the information important for the task. So another type of projects that we have is really applied projects. So that could be of interest to many people in the audience. So we really develop tools which are used in production for reading assistance and also reviewing assistance. So one instance of such a tool is a platform called CARE. We use this for internal peer review, and we also use this in our classes where I have like 600 students writing texts to support peer review in the class, since obviously it's almost impossible to grade everything by hand. So, and even if grading is more or less manageable, giving peer feedback, which is extremely important to teach computer science students produce scientific text, is not feasible. So we need to rely a lot on peer review among students in order to facilitate this process. And since students do not really trained to provide peer feedbacks, the tool provides some assistance in order to teach them to provide a good review. Yeah, so that relates to the area of AI for peer review, actually, in the scientific domain, and I will be talking about this a bit later in my talk. And so finally, the area of InterText modeling, where we understand fine-grained relations over multiple documents that I've already introduced. So now in the main part of my talk, I will talk about the challenges a bit that we faced in collecting peer review data. So during lunch, I already realized that not only us facing these huge challenges, and then I will present an example from the text generation domain where we use large language models to facilitate some of the tasks in scientific text production. And then I provide some outlook and talk a bit about ongoing projects. So getting the data has turned out to be a great challenge. So I spent several years on this. Why is it so difficult in our case? One could think in the scientific domain, so in my field, all of the content is under free copyright, so you can just take it. However, in our context, we not only need the final version of the document, we need different versions of the document, for example, the submitted version, and also we need the peer reviews. And that makes it very challenging because you have not a single stakeholder like the author of the document, but you have multiple, like the program committee, the reviewers. So you need to get everybody on board with that. And there are no established practices in peer review. I actually faced a lot of resistance from my scientific community when I came up with the idea of collecting this data. So there was a lot of resistance, and it took me several years to fight the committees in order to enable this continuous data collection. And there are a lot of issues that productively or constructively came out of that discussion. So for example, we realized the non-trivial issue that the reviews may disclose confidential information, right? So if the paper is not accepted, or even if it's accepted, the reviews may contain some important ideas about future research, for example. So even given the consent, there is some issue here in making this information available. So what I mean to say, it's not enough just to ask the reviewers. We also actually have to ask the authors for the reviews, though they are not the author of the review report. Another issue that came out is like we need to proactively teach the users who give us consent about the risks of being de-identified, right? So usually the peer review process in my community is anonymous. However, if they donate their data, somebody can adversarially train a classifier, because we have big corpora with papers written by specific people, and they can de-identify the person. And it's not enough just to ask for consent. We really need to put in big letters. So this is the risk you subscribe to. And what I mean to say, a big challenge in these kind of data collections is even to identify these risks, because we need to develop a special skill how to imagine some adversarial scenarios, and this is not very trivial. I think in cybersecurity, people even get PhDs for this type of work. So there are many important questions that determine at the end of the day if the data can be used by the community. And peer review is a good example of such a complex data situation. And there are many ways in the community how to deal with this. So one is quick and dirty, just scrape the data, just take it, right? But from the ethical point of view, this is not very great, since a lot of data, for example, is not clearly licensed, right? So it's a gray zone, so to speak. So the second approach is to look for open sources. So there are some open science platforms which are clearly licensed. They are cross-domain, and there is both manuscript submission and camera ready and some reviews that we can get from there. But these data sets are comparatively small and mixed in terms of their quality. And then the third approach, and this is actually what we have done, is the data donation approach. So here we basically have developed a very complicated protocol that we have agreed both with the executive committees of my community, which is about 10,000 people, so it's a large community, and with the ethical boards of the university after multiple iterations. And then we implemented this protocol in our centralized peer review infrastructure. So the main point here is that though initially we do not get a lot of consent, since we need to get a consent from authors, from the reviewers, from the program committee in order to release a data instance, but this big infrastructure is used for multiple big conferences every year. And what I can tell you, we have been collecting this data maybe for like 4 years now. Every year, the number of people who consent is growing. So people just get used to this, and they also see there is a lot of improvement in peer review process coming out of our work, and no disaster happens. So the fears of people decrease over time. So there is one big drawback in this data collection. So as you see in this graph, just intuitively, it is very skewed towards high quality papers that get accepted. So people who are rejected usually are not very much willing to share this information for obvious reasons. And this is a problem for resulting technologists, right? Because they need to see both instances of good stuff and bad stuff. But I think also this issue can be overcome with time. As I said, we continuously collect data and the number of negative and borderline instances is growing. So another source where we collected the data is Open Science, this F1000 corpus. So there is such a platform where people can submit their manuscript, and it is clearly licensed, and then they get reviews from peers in the community, and then they can revise and also write editorial notes. And the good thing about this source, though it's comparatively small, compared to my community, for example, which generates a lot of content. But here we have different domains. And as you know, peer review practices differ extremely from field to field. So that gives us some insight how things in biology or social sciences are different in peer review. And also we can adjust our algorithms to these specific domains. So examples of tasks we work on are linking. So here we want to find the anchors in one document, and then we want to find the targets in the other document, and then we can link two pieces of text. And this generic formalization can be applied to tasks such as citation, span detection, or plagiarism detection and evidence detection. So it's a very generic technology that can connect two pieces of text in different documents by some kind of semantic relationship. So another task we work on a lot is we study the change of documents over time, since in the peer review domain, it's quite urgent, to relate peer reviews to the document and to the changes made in the document, for example, to see if the changes satisfy the requirements of the reviewers. And this task also can generalize to a lot of use cases, for example, student essay revision analysis or Wikipedia edit analysis. And here, in previous research, people studied only like short changes, short edits. But in scientific text, as you can easily imagine, usually you have two versions of the text with a lot of changes. Okay, so we call this long scope revisions because there are many revisions. They can be also very detailed in two versions of the manuscript for which a new technology is needed. And this is true for many types of real-world scenarios. And the last example task is pragmatic tagging. So as you know, peer review has a job. So we want to improve the manuscript. There's a pragmatic purpose, and that's why the review would typically contain sentences with specific pragmatic functions, such as, for example, a sentence that encodes a recap, what the paper has done, weaknesses, strengths, to-dos, and other comments. And in this task, we collect data that classifies review sentences in terms of these categories, so we can automatically recognize them. And we have also run a shared task on this a year ago. So the second area I want to cover a bit is text generation for the scientific domain. So obviously it is very, very hot since many people are willing to have automatic support. Writing text is tedious. And there's all of this controversial discussion if we really want to produce so much text, because we already have too much text. So who's going to read all this text? Again, the AI is going to read this text. So it seems like not a very healthy kind of cycle, but I'm exaggerating a bit, right? So we are thinking of good uses of the technology in a controlled setting. And one of the projects that we have been working on here, published in last year ACL conference, is a holistic framework for document revision. So here we want to study the relationships between reviews, paper revisions, and change summaries. So everything starts with the original version of the document. For example, an author submits a paper to a conference. And this paper would receive several reviews, and the review would make some requests to the author to improve the manuscript. And usually, in response to these requests that we extract from a review, the author will revise their document. What does it mean technically? The author will perform different edit actions that have specific edit intentions. For example, the author will add a paragraph. This is the edit action, to add a fact to support their point. So to provide more evidence, this is the intent, right? Or they modify a sentence. So this is the action in order to improve grammar. This is the intent. And technically, if we have two versions of the document, we can extract all these changes and we can label them with actions and intents. And the reviewers or editors would need to check in the end what changed and if the issues raised by the reviewers were addressed. So usually the author would write some kind of a summary of these changes that we call a response letter or amendment notes, or the letter to an editor, depending on the community. But the idea is always the same. It's a summary of the changes that we have made to the document. So our work is a general framework that can apply to many such document editing scenarios. So it's not specific to the scientific text, but we use scientific text because we have it available. And also we can study some higher level questions like, for example, the dynamics in academic writing or in specific disciplines. So there are social science researchers which might be interested in such questions. So we basically provide an enabling technology for this. So we took these research papers, reviews and revisions from the data that we have collected. And then we developed an approach to align these long document revisions using our in-house Inception annotation platform that many of you would be familiar with. It's quite popular in social sciences and humanities, and we manually labeled each edit with edit action and edit intent. And we employed some iterative quality management procedures until we reach substantial inter-annotator agreement that says that this data is of high quality and is consistent to train an automatic classifier. So in addition to the edit labels on a subset of this data, we connected the revisions to the review sentences, and we asked human annotators to write these edit summaries, basically response letters, from pairs of long documents and lists of edits, and the resulting large corpus lays foundation for empirical study of long document revision and NLP assistance in producing these summary notes, AI supported. So based on this corpus, we can study different tasks, or we have actually studied the different tasks. This work is published. Such as like automatic revision, alignment, edit, intent classification, revision request extraction from the review, and document edit summarization. So my favorite task is, of course, this document edit summarization. We can use our nice large language models to get rid of tedious text production work, and we prompted GPT to generate edit summaries, and we compared this with human written summaries. So that was just a pilot study. And yeah, we have got these results, so which are pretty good actually, right? But you need to keep in mind that we prompt the model already with edit actions and intents, so the task is not much difficult. But when looking inside the summaries, we realized that the automatically written summaries are quite different in nature to human written summaries. So it's actually very easy to distinguish machine written and human written because their logical structure is different. So I skipped this. Actually, those slides were invisible, but in converting to Google Slides, they became visible. I'm sorry for that. So I proceed to
You have about
the Outlook.
5 minutes.
Yes.
Yeah.
So I'm at the right place, actually, if not the technical bug. So as I said, the project is quite large in scope, and we work on other things in this project, like basic technology for cross-document implicit linking. So this is where it's not that easy to link two snippets of text. There is no explicit reference, like in the second paragraph of section so you did that, right? So this is an explicit one, but implicit references are much harder. And here we want to train a tool where a user can provide some examples of the relations they are interested in. For example, review request and the place in the document where this review requests relate to. And we can user adaptively train such a system, so not dependent on a specific relation, right? So this is a big innovation because usually in the past time you need to train a huge, to label a huge corpus, but it's a lot of work. And we want to now use this interactive machine learning in order to be able to adapt very easily to new tasks. Then we work on human AI collaborative writing. We discussed that a bit in the previous session, so that I think in future human AI would collaborate on a joint artifact rather than the current dominating prompting paradigm. We are also interested in social science aspects like temporal dynamics of the scientific community, known under the title Science of Science and Novelty Assessment. So in novelty assessment, this is ongoing work. We want to facilitate the assessment of novelty by the reviewer in a technical domain, right? So I don't know much how this works in social sciences and humanities, but in computer science, the technical novelty is a major thing and is extremely hard to assess because you need to analyze additional sources. And usually in the data, you will have this rational, the work claims to be novel, and then you have reviews that have sentences that somehow characterize the novelty. And the reviewer would say it is novel or not novel and give some evidence for what they think about the novelty of the work. So what we do here is basically a system that can use large language models in order to assist reviewer in assessing the novelty of work. So in one configuration, we just give the abstract and the title. In the other configuration, we use retrieval augmented generation, where we use large databases and their APIs in order to retrieve, for example, 10 most relevant papers in order to be able to judge the novelty even better. And yeah, we have some baselines of already existing systems which show that they, to some extent, can already classify the novelty of the idea, but the results usually still leave a very large room for improvement. Why is it so? Because novelty is really hard to judge. So it's a good research question. So many things in the scientific domain are hard to define. Somebody was talking about productivity of researchers. The main challenge here is that we don't really know what it means. So the person writes a lot of papers, or the person has a few but very impactful ideas. So in science, there is no agreement on this. And also this may differ from one discipline to the other. Yeah, that's all. There are many challenges ahead, and I thank you very much for your attention. This is a great audience, and I'm really looking forward to the discussion.
Thank you. We have about 20 minutes. I see, let's see, many hands. Would you prefer to take the question and then answer, or should I collect? Any
Or maybe
preference?
question by question is easier.
It's easier, huh?
I
Yeah.
said, like, humans are very limited in terms of memory and attention. This is true for myself as well.
So I have Pierluigi, Gert, Arno, Raphael. Let's start with these four, but we take each in turn.
So I have a question about the document edit suggestion, automatic suggestion. I've been heavily involved in the reviewing process of ACL as an author and as a reviewer. As a author, one of the most annoying part is when you get these reviews that look like they've been generated by AI or like they are really being generated by AI. So I wonder how to filter out these kind of things, because I guess also the data set has been developed recently, so it can be that many of these reviews are actually generated by AI.
Yeah, so I think the number of AI-generated reviews is growing, but I don't think it's really a vast majority of reviews. We submit quite a lot of papers. We see one every now and then, but it's not like a massive problem. And this data set has been collected in 23, so it's actually a bit older. I think now it's getting worse. So one work we have currently in submission to ACL is on review aspect detection. And aspects provide a kind of abstraction to a higher level. And one of the tasks that we have explored, like an extrinsic evaluation of aspects, is they are used for detecting these AI-generated reviews, and it works pretty well. Because as I said, we found in this study, but it's, I think, a common knowledge that automatically produced text is different from human-generated text, right? So it sounds metallic, it's very generic. And by having the semantic level of abstraction to review aspects, we can filter that pretty well.
It would be very useful to improve the whole process.
Yeah, indeed. But these reviews typically would be given low weight by the action editor. It's just like a pity that people waste their time in reading them.
Thank you.
You're welcome.
Thanks. Gert? And then Arno.
I'm particularly interested in one of your steps of intertextuality to establish it. So the key element that's clear is the identification of the action to revise a text by the author or by others. And part of this revision action is the identification of the intent. And you have an intent editor even there. But both the theory of intertextuality and the praxis show that you have not the slightest evidence to establish intents of changing intertextuality, because it's very rare that authors annotate their intentions. So you don't find a trace of it. And it's also quite clear that from the retrospective, the identification of even one's own intent is very deformed. It's fault. So there is a systematic difficulty to identify correctly the intents to change even one's own texts. I wonder how you address this challenge.
Yeah, I almost expected this question in this audience. So in my talk, I emphasize specifically for you guys, like there are these intertextuality theories. We are very much impressed. They are very complex and there are competing theories. So there is no agreement, right? And usually in my field, because we need to make this codable in data, we simplify them very much. Right, and also we do not try to do this like very broadly. So we do not model the intents in, for example, philosophic literature evolution, at least in the current stage. But we use data from specific domains where we can kind of pragmatically identify this in a corpus-driven manner. So this is our methodology. Just basically, we narrow down the use case, we simplify the underlying theory, and then we have people coding the data until we get good agreement. So we spend quite a lot of time on that in iterating and then improving the annotation scheme.
My comment goes in the same direction as Gert's with the theories of intertextuality. Like people like Kristeva or Bartes, etc., they have emphasized the active role of the reader and the person, not so much the authors, but the people picking up this may help to get rid of the question of what's the intent of an author, okay? But even we can even maybe agree to say the intent doesn't even matter. The question is what the action is, what do you actually take from it? And you could find traces, but still you wouldn't have the causal link. I mean, in your case, you have it because you have these cool structured data, and it's clear that this is the review. It tells you something. So the causality is clear that this text causally influences the other one, even if we get rid of all these intents and authors. But how is there ways to when you go out in the wild? I was actually thinking, because I did some work actually with people Benno Stein and Martin Potthast on Wikipedia, on editing revisions and so on. And the question is, when people edit these revisions, we sometimes have an understanding, okay, probably they were prompted by some Nature article that came out, and that's why they made this edit or something. But I mean, of course, we can only speculate. So are there any ways to get at least the causality of it, even if we cannot get at the intents?
Yeah, I think in your case, there is really big impact from outside, right? But in the scientific domain, there is such impact. For example, some competitor paper being published at the same time, but it's not so pronounced, right? So mainly the changes are really caused by these review requests. This is what we call this, but also additional experiments that people have done in the time between submission and rebuttal, and these extrinsic events. The next version of ChatGPT came out, and we need to adapt our claims or something, right? So I think this is like the next level. We have not addressed this in our work scope, right? So as I said, we need to go step by step, and also in this respect, again, we need to create some data set which can be as complex as hell, right? But this is an interesting research direction. I completely agree. So I just want to anecdotically mention, like in the past, as you know, I worked for many years in argument mining, and also on argument mining in scientific literature. And at some point, I had a PhD student working on extracting arguments from educational research papers. This is an instance of social science papers. And I have to admit, we miserably failed. Right? So, I mean, in technical discourse, or we took an empirical educational research journal papers, it was okay. So we could manage, right? But empirical, like the educational research has also this qualitative type of community, and they cannot agree on the argument made on the paper. Depending on the background knowledge of the reader, they interpret the text in a different way. So now, if there is no consensus about this, there is no agreement, it's impossible for us to develop a classifier, right? Because machine learning is statistical patterns. There is no pattern there. And I think like in these domains where there is no like ground truth, basically, that's the consequence. What we can do, and I find a very good research direction, we can develop tools supporting this particular experts. Right, so this is kind of what another famous HCI researcher I like very much, Albrecht Schmidt, calls this rethinking thinking. So similarly to this revolution when we were able to print books, right? So it was a huge democratization of knowledge and a real revolution in the society at this age. So now with LLMs it's similar, because we can externalize a lot of memory, basically, and I think the nature of our work will change very much, because many things like Latin, we don't need to speak Latin anymore, so the skill is not needed anymore. So many skills that LLMs can replace, they will become unimportant, but other skills will become very important in knowledge work. For example, how to steer LLMs to high quality output. I can talk for a long time, sorry.
Let's take Raphael. I think I saw two more hands, one hand here, one hand here. And Malte, I'd have a question too, but I let them first.
So Raphael has already.
Raphael is cancelled. Okay, so then I saw, I forgot the name, sorry. And then Jochen.
So my question is about human AI collaboration. I'm very concerned about this. You probably know about vibe coding trend.
Which coding?
Vibe coding is called, when people are relying on AI to produce software, and the problem that they don't understand how it works. And you can see a lot in LinkedIn, for example, long posts, they are usually produced by AI. And what is your opinion, how we can prevent this?
So I definitely want to change this. So I don't want my PhD students to come to me with some program they cannot explain, right? So we cannot work with this. So in this human AI collaboration, so my vision is that, as I said, we have a hierarchical work structure. So first we need to create an abstract model like specifications for what I want to do. Then we need to create an architecture of the system. And in each step, the human collaborates with an agent, right? And then this thing unfolds, and that would make this joint solution co-construction. So this is what we term this. We have a vision paper about specifically this, including code generation, right? Makes it accountable. So that's why I made this point in a previous talk's discussion, that I think that the human AI cooperation is going to be the future mode, how we interact with this system rather than using them in a monolithic way. So this is something that you raise.
But how do you know that your students not cheating?
Sorry, we have a couple of more questions. We should go. I think it would be a pity to lose them. I saw Jochen. Is it then Malte? Can you? And Vera.
Thank you very much for this talk. I was really inspired. And two things or three. How do you see the? Could you also apply your system to margins of text? I mean, it's also a kind of intratextuality.
So margins, you mean like comments on the text?
Yeah. So if you have like a corpus of, say, a person that has intensively annotated a library, so that's also some sort of intratext.
Yes, of course. I mean, the intertextuality theories come from, even Bible was commented in a similar way, right? So very old text. And what we try to develop is built on top of a very generic model of intertextuality, right? So the model as such is very generic. So there's a long article of 50 pages about the model, right? But we instantiate this in a set of selected domains, right? Not covering this particular scenario, but other people could take the approach and apply this in other domains, right? So this is just like a very huge field. So we need more community to join along these lines.
Actually, what if I just a quick one. So you mentioned the invention of the printing press, and now there was of course a process of homogenization. So how do you see LLMs and homogenization of knowledge? So do you think that's a problem?
Well, I mean, so this is a new question. Cannot recall an answer directly from my parametric knowledge, right? But let's think step by step. So there's not just like one LLM, okay? So there are hundreds of large language models, and they are trained in different ways, using different data, and also using different training methods and architectures, right? And I think this defines what the model is doing. And because we have a huge variety of models, probably, there is not a homogeneous output. And also, as I said, if you give the same prompt, the model will give you different outputs, right? So there's a big variety. There is no ground truth. And in many real-life problems, so this is something we discuss in this vision paper. So there's not just one particular solution, but there's a space of possible solutions. They have specific utility. This is the technical term. So how useful they are. And we need to navigate in this solution space, basically based on the preferences expressed by the human, right, to the AI agent. So there are many challenges. We need to extract and understand these preferences, but basically, so we will, it's a search-based paradigm in a large solution space where there might exist different solutions of equal utility. And the objective is we align the resulting solution to the preferences of the given human interacting with the system.
Okay. Any details you can take to the dinner? Vera has a question.
Yeah, it's back to your research about reviews. So I wonder, do you somehow previously classify into good and bad reviews, helpful or not helpful, which that should be prioritized? And do you consider seniority of reviewers? Because you mentioned like junior reviewers may be less helpful. I also noticed that some junior reviewers that tend to, maybe they're not junior, but I think so, do very detailed reviews, while senior reviewers can like throw out a question and then how this person responded may be a solution or not a solution, and it's difficult like to assess.
So this is a question about the review quality assessment. This topic is extremely difficult, right? So we have some sense what is a good review, but also a review may be good for different reasons. I think this is what you are hinting at. And I think it's a very strong assumption that junior reviewers would not be very helpful. So in my experience, they can be extremely helpful if they review a paper in their specific subject domain. Because they have very detailed knowledge of this and may provide kind of comments that are grounded in hands-on work, which a senior reviewer like me will not provide for sure, right? Because I can make more generic like comments, more high level, not generic, but high level, and very important about the impact, right? I have much longer history to consult. So there are just different reasons why a review is helpful or not helpful. That can depend on the subject, on how well the reviewer is aligned with the paper, on their level and type of background knowledge. But one project that may be of interest to people here, I am involved in quite much. Right now, we want to develop a reviewing agent for AR. I think you were asking questions about AR. That will help to identify like lazy thinking, for example, in the review. This is where people complain about the lack of novelty, but actually do not explain the reason, right? Or my work is on German, but they complain I have not applied this to French or whatever, right? So these are not valid scientific arguments. So this is what is called lazy reviewing, and ACL has a whole catalog of such reviewing flaws. And we are developing an agent that we hope to deploy in a real-life system that will kind of highlight such issues in a review.
It would be helpful to have also argumentative structure of reviewers, which is not, of course, the case now. But for us to parse these argumentative structures and understand like why they are arguing.
I don't know which community you belong to, if I may ask.
The same as you.
Yeah, but we do have weaknesses and strengths. I mean, these are arguments. And I was a PC chair of ACL 2018, and I introduced this more structured approach. So before that, the reviews were completely free text. But then a lot of people complained. Why do they complain? Because they need to apply intellectual effort to get these arguments clear, right? And one can review the process in many ways, but I think we all face the challenge of a huge explosion of literature that nobody can read. So we need also to rely on partial knowledge in reviewing, right? Because nobody can read all the literature in a given domain anymore, right? So that's why it's an area which deserves a lot of research.
Okay, so we're coming to an end. I found this very interesting, just to give a little hint of what my comment or question was, that you're addressing here issues in peer review and so on, and the methods that you use, text revisions and so on, have, I think, for many in the back of their mind, interesting application in sort of history of science, where you are interested in exactly these versioning and revisions of text, not because of doing better reviews, but because of understanding the scientific development better. And I like this very much, so to try to think about these possible applications.
Yeah, so people interested in that are very much welcome to have a conversation, because we are actually very much interested to apply this technology to various interesting questions, right? But we usually, so my students are very technical people. It's not our expertise, right? So that's why we also stay in our domain in terms of empirical data, because this is what we can judge. Otherwise, we need a partner with this particular expertise in order to judge the results.
Yeah.
So much welcome to talk to me.
Let's keep in touch. So let's thank Iryna Gurevych again.